So let's move on now to some new reactions for synthesizing amines. This is going to be preparation of amines. And all of these reactions, there's going to be 3 reactions that we learn here. These are all going to be substitution reactions. They're all SN2 reactions, but they use really clever reaction conditions or situations that might not be totally obvious to you if you were seeing them, even though you're very familiar with substitution. So the first one that we're going to look at is called alkylation of ammonia. Ammonia being NH3. And alkylation referring to just putting R groups or alkyl groups on the nitrogen. And we do that, I left a space there intentionally because we're going to add something there. We do this using alkyl halides. It's an SN2 reaction, like I said. We're going to draw the mechanism. And there's 2 different ways that we can do this alkylation reaction. So I'm going to write the second option over here. This time, no space in front of the alkyl halide. So the alkylation reaction, when you're mixing ammonia with an alkyl halide, it's a pretty favorable reaction, and it's also really uncontrollable in terms of stoichiometry. So if we just mixed an ammonia with an alkyl halide, some of our products would come from the 1-to-1 reaction. So we would end up with like an NH2R. But some of the ammonia molecules would get alkylated twice, so we would end up with this NR2H. And some of the ammonia molecules would get alkylated 3 times, so we would end up with an NR3. And some of them would even get alkylated 4 times, NR4 plus. And because many of them are being alkylated more than once, we're also going to end up with some unreacted ammonia as well, and that's a lot of different products. It's not ideal. And this again is just because the reaction is really easy and favorable, and we cannot control the reaction by controlling the stoichiometry. So knowing that we have this situation, we have 2 options to kind of approach this alkylation reaction. One option is to run the reaction with excess alkyl halide. The other option is to run the reaction with excess ammonia. Those are our 2 choices. If we run the reaction with excess alkyl halide, what we're doing there is guaranteeing that every single ammonia molecule is going to get totally alkylated. That means 4 R groups on it. Everything is going to react and put as many R groups as possible on the nitrogen, and that's what we will end up with as our product. Our other option is to reverse the excess. So this time we have option number 2, we have excess ammonia reacting with alkyl halide. In that situation, what we're trying to do is minimize the statistics, minimize the opportunity for a nitrogen to get alkylated twice. So in this reaction, we will end up with just a single alkylated nitrogen and a primary amine. So this is making our quaternary ammonium. This is making our primary amine. Quaternary ammonium we get when we have excess alkyl halide, and the primary amine when we have excess amine. So it's not ideal because there is no way to make secondary or tertiary amines using this reaction. It's all or just one. Let's look at the mechanism for this reaction because it is a really nice and simple mechanism. And it's one that you'll be drawing on sapling. And so we do always start with ammonia. And for our alkyl halide, let's just use something that's easy to draw. So let's use just like this bromoethane. And like I said, this is SN2. So the reaction will start by the lone pair of electrons on the nitrogen attacking that carbon with the leaving group and getting rid of the leaving group. And this is the intermediate that we make initially. And then we have another NH3 molecule that comes along because remember these are bases, the ammonia molecules are bases, and it will just deprotonate one of the, it'll deprotonate the nitrogen by grabbing any one of the hydrogens, and this gives us our first, this would be our monoalkylated product. Now, if we were running the reaction under these conditions right here, where we had excess ammonia, we've got tons and tons and tons of ammonia, the chances of our product, our monoalkylated product, bumping into a second alkyl bromide and reacting again, the chances are very slim. The chances are slim because we have flooded the reaction with NH3. So most of the collisions that take place will be collisions between NH3 and something else. It could be anything else. It's going to be running into anything. So by flooding it with NH3, we've minimized the chances of any other reaction taking place. If we are running the reaction under these conditions here where we have excess alkyl halide, in this situation, we have flooded with alkyl halide. And so most of the collisions that occur will be an alkyl halide colliding with anything. And that's how this reaction will continue, like in a second round of alkylation. So as the reaction continues, that lone pair of electrons again grabs another, in this case, another ethyl group, and makes a positively charged nitrogen. And that positively charged nitrogen is going to get deprotonated by, I'm always showing it being deprotonated by ammonia, but it certainly could be deprotonated by any nitrogen with a lone pair. It doesn't have to be ammonia doing it again. So now we have this guy. I'm just kind of redrawing those alkyl groups to make it look better. And remember, in this case, we have a flood of alkyl halides. So we've got lots of alkyl halides running around, and they're going to collide again with another nitrogen. And we will end up, now we have a trialkylated amine. We've got 3 alkyl groups on it. Deprotonate again. Any nitrogen with a lone pair. By that I mean, so maybe something in this stage could be doing the deprotonation, or something in this stage could be doing the deprotonation. Anything could be doing it. Anything with a lone pair can be doing it. Grab that last hydrogen. And it would be super if the reaction would just stop right here at a tertiary amine, but we've got this reaction flooded with alkyl halides because we can't control the reaction at all. If you can't beat them, join them. So we have it flooded, and that means that we are making, we're going all the way to a quaternary ammonium.